Okay, so we have systems by graphing, which is two or more equations with the same set of variables. For example, we could have y equals 4x and y equals 4x plus 2. Those are two different equations, but they still have the same variables. They still have x's and y's. Okay? Now we use systems of equations to solve for x and to solve for y. So sometimes you're given a word problem, and it says something like, Johnny bought 3 sodas and 4 chocolate bars, and the total was $13. How much were the sodas and how much were the chocolate bars? And this is a pretty standard type of systems of equations word problem. So you have to be able to set up these equations, and then you have to solve for each one. Okay? So on the last benchmark, we gave you an extra credit question, kind of like that. Do you remember at the end, and it was like they went to the movies, and you had to figure out how much the popcorn was? Do you remember that?
The sodas were.
Yeah, that was a systems of equations problem. Okay? So if you got that right, maybe you got it right by trial and error. Some of you actually knew how to set up the equation, but it was very few of you that did that. But that's exactly where we're going. Okay? What you're going to do with the graph is I'm going to show you how that we can also solve these systems by graphing. Okay? It's a very simple way. If we can graph the lines and figure out where they intersect, that would be a solution as well. So the first thing we'll do is solve by graphing. I highlighted the two equations so that you can see them better when we do graph them. So go ahead and write them down. You could label them A and B. You can highlight whatever works best for you. So we have two equations. Y equals negative 2x minus 3. Y equals 2x plus 5. So if I can graph these lines and figure out where they intersect, then I have a solution. Whatever that intersection point is on the graph, that's my answer for x and my answer for y. Okay? Or for my answer for sodas and popcorn, or my answer for whatever it is. Okay? So here's what you're going to do. You're going to glue your little graph paper down. Then you're going to graph each line, which I highlighted for you so you can see them. Find the point where they intersect, and then you can plug it back in to make sure it works. So go ahead and do all of this information here. Glue your little graph paper somewhere on there. Graph each line, which I highlighted. Find the point where they intersect. I give you a straight edge so that you can be precise. So use that straight edge. Okay? So protractors are on your desk. Glue. The information at the bottom there is just when I plugged the negative 2 and the 1 back into the equations for x and y. Okay? So you can always check your answers on these type of problems too. If you get it wrong, you know you have to go back and regraph or something. So just to recall, those of you who are ready to graph, for the first one, which I labeled A, the green one, you start at negative 3, because that's our y-intercept. We go down 2, right? Down 2 over 1. That's the negative 2. So start at negative 3, go down 2 over 1. Use your straight edge. Connect the dots. Then for line B, which I did in the pink color, we start at 5. So you put a dot up here at the 5. And our slope is 2. So we go up 2 over 1. Okay? And I wrote them here for you too if you just need to see what lines are what. And then after I connect both lines here, I realize, oh, this is the point of intersection. And this point right here is negative 2, 1. Negative 2, 1. And remember, negative 2 stands for the x value. and 1 stands for the y value. So if I want to check to make sure it works, all I have to do is put 1 where the y is and -2 where the x is, and that one worked. And again, 1 where the y is and -2 where the x was, and that one worked. When you're checking if one of them doesn't work, then you either graphed wrong or maybe you didn't use a straight edge or something happened there. Any questions on this one so far? So after you guys finish graphing that and writing that down, I want you to try 2 of these. On page 234, there's 2 problems at the bottom, A and B. If you don't have your book, you can use a little bit of extra graph paper to graph them there. But I want you to try those, and I'll give you guys about 5 minutes. And then we'll go back and see if there's any questions.